I'm going to be going over the shape recognizer. I sent a bunch of information on the Slack on how to make one, and hopefully you guys were able to figure it out based on what I sent, but if you weren't, we're going to go over it right now. So of course we start importing OpenCV. We're always going to do that. And for this, you could have, if you really wanted to, drawn something on a piece of paper, but that would be a bit hard to recognize. So I just created like a square and a triangle in MS Paint and just saved it as a image file. So the way you read an image in OpenCV is just imread, and then you put the name of it, assuming it's in the same directory. So I'll use triangle.png since I have that on my desktop. And when we input this, I think I made my triangle like red, so we want to convert it to grayscale. That way we can filter the colors easier. So we'll put gray here equals to cv2.cvt color, and this is gonna basically convert it. So we do cv2.color underscore, and see how there's BGR to gray and RGB to gray. Normally images are in RGB, but the imread reads it as BGR, so we want this one. Now that we have our gray image, we want to have a threshold value. So basically this would be making, I believe the background of the triangle image would be black, and the triangle itself is going to be sort of a light gray. And so that means that we have to flip that, since contours are always going to be white, and we also need the threshold to basically turn the image into 1 or 0, like the pixels on or off. So we can create a threshold by doing cv2.threshold, and we're going to import gray as our source, and the threshold we'll do like 127, and the maximum value we're going to have is 255. And the type, I believe for this, there's different types of thresholds that we can do. We want binary inverse because we want to invert the image. And so now that we've inverted it, we've gotten the threshold. Now the image is basically, well, threshold here. This image is going to be in 1s or 0s, so only the contour is going to be 1s, the rest is going to be 0s. But we still have to find this, and if there are more than one, we'll do contours H, and we'll do cv2 find contours, and this will just return a list of all the contours that are present in the image. So the image we want is threshold, and the mode and method, we're just going to do 1 and 2. I forget which one those, spelled that wrong. I forget which ones those represented, but if you really want to dig into it, it's probably in the documentation somewhere. And so now that we have a list of contours, there's only going to be one since I'm only passing in a single triangle, but let's say that there were more. So we'll do CNT for short, contour for short, in contours. This is going to be looping through all of the contours that we have. Now the actual function that we're using to recognize the shape is called approx polydp. It uses, I believe it uses like curves and stuff. I'll send the Wikipedia link to the algorithm it uses later on Slack if you want to read into that, but all we care about is that it can tell us the number of sides our shape has. So we'll do cv2.props polydp, and we're going to pass in our current contour, which is CNT, and here I'm just going to paste in a bunch of predetermined arguments for the function, because again it's just using arcs. If we look at the arguments of the function, this stuff is just all relating to the curves that it's finding, but again for now all we really care about is the number of sides that it's returning to us. And so approx is going to be the number of sides. All that's left to do is have an if statement. So I know that we're passing in a triangle, so if approx, actually we need the length of that. If the length of a prox is equal to 3, then we're going to print triangle. And we'll also add the square since I have one of those in a JPEG. And now on the outside of our loop, we can just we don't really need that, but hopefully this works. Yeah, so we passed in the triangle image and that it printed out that it's a triangle, and I'll send triangle to the chat so you guys can see what it looks like. There's triangle.png and here's square.jpg. We'll do the square next to see if it works. So now it should hopefully, yeah, it says square. Now, some of you guys might know or be familiar with IMRead. There's flags here. We could import it as IMRead grayscale, and we wouldn't need this gray here. But I believe in order to run the threshold function on the image data, we'd need to, I think it's still, the grayscale might not be in the proper format. Like when it inverts it, I might mess it up or something like that, but we could actually try that. We can try just passing image. It'll either have an error or just not print anything since it won't be able to detect contours. So we'll actually try that. Yeah, it has an error when we do that. I'm just curious, what is the error? Invalid number of channels in input image. Are we just converting it wrong? Oh, it might be because of this line. Oh, that works too. So we don't even need this line here. We'll actually double check triangle.png. Okay, I guess it doesn't work with the triangle because I believe the triangle was red and it might be loading in as a light gray, which doesn't like to work. What if we lower the threshold? 1. Yeah, that doesn't work either. So I guess we do need this conversion to grayscale. Does approx poly dp just approximate by taking the minimum shape of the closed contour? I'm not sure what you mean by minimum shape. I'm pretty sure it does a bunch of magic math with curves and arcs, which when I was reading the Wikipedia article last week to try and get a better understanding of it, it didn't make any sense. So if you guys want to read into it, I'll send the link on Slack. But this is basically the simplest version of a shape recognizer you can make in OpenCV. It only took us 17 lines, but if we wanted it to recognize, say, like a really complex shape like a hand, since in the end when your hand is in front of a camera it's just a shape. If we wanted to recognize that, we would probably need a lot more than just approx poly dp. Since if we passed in a circle, it would just give us a really big number. So we could actually do if this is greater than, say, 14 or 13, 15, then it would probably be a circle. And you could, of course, keep adding shapes, but assuming you guys understand this, we'd probably have enough basic OpenCV info that we could, next meeting, start going over the code and figuring out how to make it run faster on the Raspberry Pi, which, if I recall correctly, most of the delay between getting the vision from getting the vision data from the Python program to the Raspberry Pi running the actual robot on it was the networking. So if we could figure out how to transport data over an Ethernet cable or something like that, maybe even just raw serial data through a USB cable, then we would basically complete our objective. And that would also save us having to figure out how to actually make the vision process faster, which I don't know if there's much margin for error in that. It's not the nearly infinite number of contours, it's the sides. Since the circle itself is going to be a contour, but yeah, it would just return, depending on how many pixels the circle is of, approx poly dp is going to return that it has a bunch of sides on it. And so that's why we can just do, if it's greater than this, it's probably a circle. Yeah. Although it could be a half circle. And that's one of the flaws of approx poly dp. There are some other methods that use like the outline of a shape. Some you could even use machine learning, but I guess that's it for this meeting. I'll decide what we're doing next meeting. We're probably gonna, I'll link it after this meeting. Yeah. So you guys are free to go. If you can stay behind if you have any questions about the code, but I'll let you guys know on Slack what to prepare for next meeting.